just a second. Yeah, so we're using our inverse, hyperbolic, and inverse trig functions, right? Oh, yeah. So for this tan, we said that tan is the derivative of arctan is going to be equal to, with respect to x, it's going to be the derivative of u all over 1 minus u squared, isn't it?
Yes. Minus, yes.
Is it minus or plus?
Mine, let me check mine. Because I confuse it with the hyperbolic.
Because
they're the same, but the one is negative and the other one is... Yeah, so this one is actually positive. So it's 1 plus.
yes, it's plus.
Yeah.
Okay, it's plus. Okay, so now that we have this, first of all, we need to find the derivative of the function given, ne? Right, so we can call our u x over the root of 1 minus x squared, and then you can use either the product rule or the quotient rule. However, because it's a fraction there, it's fine, you can use the quotient rule. So the derivative of this would be, remember, you square the bottom part, and then you take that bottom part as it is on top, you multiply by the derivative of the top one, and get it? Right, then you say minus at the top one times the derivative now of the bottom one. Now the bottom one, remember, it's that is 1 minus x squared to the power of half, and get it? The derivative would be half into 1 minus x squared, and then remember we subtract 1 there so that we get negative half.
Negative half, yeah.
Nice. And then we multiply by the derivative of what is inside, and get, which is negative 2x.
2x, yeah.
Perfect. Immediately from there we can see some nice stuff that is happening there. To say, okay, let me try this. Oh yeah. So to say that the 2 will cancel the 2 here, ne? Right. And then here, if we simplify it, we can say now we have square root of 1 minus x squared. Now negative times negative, this negative times negative, that will be positive. X times x, that should be x squared, right? Right. And then now it is x squared over this one, over the root of 1 minus x squared. Again, it's much better to express it this way from the get-go, because you realize that this, it becomes positive in the denominator, and a half means the root.
Yeah.
Right, and at the bottom there we are going to have let me write it like this: 1 minus x squared to the power of 2. Now someone might say, but why am I not just saying that the 2 here will cancel the root sign? Angel?
Yeah, I did that.
Okay. Well, do not rush to do that, okay? Don't rush to do that. Why? Because in most cases, in most of the problems you're going to find that the denominator is going to be, the denominator will be similar to one of the things on top. You understand me?
Yeah.
Yeah, so because of that, and especially when you see that on top or on the bottom you have a fraction, as a numerator it's a fraction, or as a denominator it's a fraction, you simply multiply by the denominator of that fraction, okay, over the very same thing, because this is like 1 and it's
That's 1, yeah.
But we know it leads us somewhere to say, when you say this, multiply by that. That's when now you can say I will have 1 minus x squared because the root cancels each other. And get. Then when you say this multiply by that, remember that this will cancel this one. And get.
Yeah.
Right, so that you're left with x squared. And then at the bottom now, remember you have this multiplied by that. The bases are the same, right? So it will be square root of 1 minus x squared to the power of what? To the power of 3.
Yeah.
Right, this is what we have. And then finally we can say we have 1 over the root of 1 minus x squared to the power of what? Of 3. Right, that is the derivative of u. Then we are literally almost done. Why? Because now we can simply then say, therefore, the derivative of y will be equal to derivative of u that we got. But we're gonna say, in fact, I like to write this thing as 1 over 1 plus u squared multiplied by the derivative of u. Ne? You get it?
Okay. Yes, I also do it like that.
Right, so we have 1 over 1 plus. Now remember, our u is the whole thing, right? So we're gonna say x over the root of 1 minus x squared all squared multiplied by 1 over the root of 1 minus x squared all cubed. Ne? Perfect. Then from there, right, from there you can rewrite now this as 1 all over 1 plus x squared. And then remember, don't rush to say the square cancels that. Write it as 1 minus x squared to the power of 2 times that. Right, times that. And then from here now we can say, how about, because we have a 1, right? How about we express this in terms of the denominator? So what you say, usually when you have 1 plus a fraction, you simply say the denominator of that fraction, which is the root of 1 minus x squared to the power of 2. You're going to rewrite it again just to form 1 using that denominator, 112. And then plus x squared all over that. 1 minus x squared to the power of 2. Right. Do not rush to kill that square root. It might assist you. Now that you have this, you can now say, oh, okay, it means on top we have, right, it's very ugly, but that is the perks of doing maths. We have to work with ugly stuff. So we say plus x squared there. And then at the bottom, right, you're going to have, right, I think I moved it to, yeah. So remember, 1 is still there on top, right? However, this, you add it to that because now the denominators are the same. So you can just say, here you still have 1 minus x squared to the power of 2. Right. It looks very ugly. But then here, right, we can try to see what's going on there. Now, since it's like this, remember, 1 divided by a over b is the same as 1 times b over a, right? So we can flip this fraction to say, we can write it as the square root of 1 minus x squared to the power of 2 all divided by the square root of 1 minus x squared to the power of 2 plus x squared times by 1 all over the root of 1 minus x squared to the power of 3. Ne? Now it looks very, very nice because now since here it's 2, right, and then here it is 3, we can try to use laws of exponents and get right to say that, oh, okay, on top we have 1, on the bottom now we can simplify this part. It's okay to simplify now to say we can now write 1 minus x squared and then plus x squared, and then we're going to multiply that by the root of 1 minus x squared, because remember we said 3 minus 2 is 1. I get it? Right, then it means finally we're gonna have this will cancel that. You're going to have 1 multiplied by 1 minus x squared, so your final answer will be 1 all over the root of 1 minus x squared. Right, quite interesting.
Yeah.
Yeah, so please.
I rushed to. I usually do that. I rush to simplify the
Oh,
denominator.
no, we just watch out for that then, ne?
Yeah.
Right, and then next one you had said it was 1.7.
Yes.
Right, let me quickly grab it. 1.7.
Also on activity 8.
Also on activity 8. All right.
Yeah.
Right, so this is what we have. Are you able to see it?
Yes.
Right, quite nice stuff here. Let's remember that now that we're dealing with chord, right? If I can remember well, chord we said it was that other side. I get it for tan it was a derivative of u over 1 plus u squared, ne?
Yeah, so cot is changing the sign on top.
Right. So chord inverse would change the sign on top. So we know that it is this one. Okay. Right. Oh, and did I tell you that you have a friend who's gonna join?
No.
Okay. I don't know if you mind though. Because she also is one of my students. So, but I think since we're almost done, it shouldn't be. I think she can benefit something. On top.
Oh, okay.
Yeah. Okay, let me see. Yeah. Okay, but we can then continue from there, right? Now remember, this is negative the derivative of u plus 1 plus u squared, right? And we always need to work with this first part first. We need to get the derivative of u first, right? So we can write that we have our u as 1 plus x divided by 1 minus x. Right, now that we have it like this, it's still a division, so we can use our quotient rule to divide that, to differentiate that. So we can say, okay, the derivative of u will be 1 minus x all squared. Then we take the 1 minus x as it is on top, then we derive the top part. The derivative of the top part will be 1. Then we say minus, and then we have 1 plus x, and then we derive the bottom part to be minus 1. Quite a nice one here. Then we can say 1 times 1, that will be 1, and then 1 times negative x, it will be that. And then we need to be careful in terms of our signs here, right? Negative 1 times 1, that will be negative 1, and then negative 1 times x, that will be negative x, all divided by 1 minus x all squared. Then we have 1 minus x plus 1 plus x, all divided by 1 minus x all squared. So this means the derivative of u, this would cancel that, right? And then we're left with 1 plus 1, which is 2 all over 1 minus x all squared. Right, this is the derivative of u. Now that we have the derivative of u, we can then simply substitute it there to say therefore the derivative of y of the whole thing now would be equal to 1 all over, remember 1 plus u squared, 1 all over 1 plus your 1 plus x divided by 1 minus x, then you say all squared, right? We say all squared because it says 1 plus u squared, so u is the whole thing, so we square it, and then we say multiplied by negative of the derivative, which means negative 2 all over 1 minus x all squared, right? We start here, then we simplify. At the bottom we're gonna have 1 plus x all squared, you divide by 1 minus x all squared, then we would multiply by negative 2 all over 1 minus x all squared. Remember what I said, do not rush to simplify this, right? Work with it as it is, right, with that squared. So the 1, remember we said we're going to express it in terms of the denominator, right? Right, so you're gonna have 1 minus x all squared divided by 1 minus x all squared plus 1 plus x all squared divided by 1 minus x all squared. Then you multiply that by negative 2 all over 1 minus x all squared. A lot of squared there, but then yeah, at the bottom now we can say, remember that these the denominators are the same, so we can just say we have 1 minus x all squared plus 1 plus x all squared divided by 1 minus x all squared as it is, and then here you have negative 2 all over 1 minus x all squared. Then remember we said 1 divided by a over b is the same as saying 1 times b over a, so this part here is gonna change to 1 minus x all squared all over 1 minus x all squared plus 1 plus x all squared, and then we multiply by negative 2 all over 1 minus x all squared. Nice. Something beautiful and magical happens there. This will cancel that. So because of that, what we are actually left with there will be negative 2 divided by these two now, 1 minus x all squared plus 1 plus x all squared. Now you can be in a position to try and simplify at the bottom if you feel like something can happen now. So we can say maybe negative 2 all over 1 minus 2x plus x squared, and then here you will have 1 plus 2x plus x squared, so you will have negative 2 all over, this will cancel that, and then x squared plus x squared is 2x squared. 1 plus 1 is what? 1 plus 1 is 2, right? Nice stuff. Hope I'm not leaving anything. Then you are still going. You can take 2 as a common factor and say x squared plus 1. So that they cancel, your final answer should be negative 1 over x squared plus 1 as the derivative. Aish, beautiful stuff, Buffett. Right, so this is what we would have. I don't know if it's correct. Is it correct?
Let me just check. Yeah, that's the correct one.
Great stuff, great stuff. That is always the procedure you do on hyperbolic functions, inverse hyperbolic, inverse trig. Ensure that you separate them. Do not work on these like, try to substitute here, right? It might confuse you along the way. Okay.
And then can we do 1.10 from exercise 8?
1.10 from exercise 8. It looks very scary, ma'am. Are you not scared of it?
Hey, if you can see my answer, yo,
Ah, quite interesting,
it
quite
was scary.
interesting. By the way, I hope you're okay, Miss Leila. Ish, you see, we're in working mode, ma'am. It's tough here, but then here, I hope you're doing very well. Um, right. So if we have this, looks very nice. Now it's cos. Ne? Let's remember that for cos, for sine, I get we said it was u all over square root of 1 minus u squared. I get like this.
Yeah.
For cos, remember we just add a negative there. Then that will be
On
for
top.
cos. That will be for cos. But remember, yeah, that will be for cos. Ne? Then now we can say let's get the derivative of u first. Now we shall say let your u be x over y. Wait a minute, what's going on? This one
It I forgot what it's called, but that one where when you differentiate y, it becomes dy dx.
so it's implicit.
Yes, implicit. That's the word I was looking for.
Because you have x and y. Okay.
Yeah.
Implicit. So this implicit maybe will want us to work on the left hand side first, then we shall proceed like that. Ne?
Okay.
Yeah, let's start with this first part first. Let's try to kill it first. Now we have x over y. The derivative of u would be in terms of y, here you say y squared, right? And then you take y as it is, you find the derivative of the top, then minus y, minus x into the derivative of y. Is this okay?
Let me check.
Right.
Yeah, that was my answer also.
Okay, so we have y minus x times the derivative of y all over y squared as our derivative of u. Then we can plug it in the formula for cos to then say we have check. Yeah, to then say we have negative of this, right? So for cos, the derivative of cos with respect to x, the derivative of cos, remember your notation as you are working is also very much key. So the derivative of this will then be negative of, okay, let me write it like I was writing it, to say 1 all over the root of 1 minus u squared, which means 1 minus x over y all squared, x over y all squared, multiplied by negative of the derivative, meaning that negative, if I can quickly multiply by negative here, it means we'll have x times y prime minus y all over y squared. You see what I did? I just multiplied everything by negative, ne?
Okay, yeah.
Right. Then it is still in the same format we were working with. So we say 1 over 1 minus x squared over y squared times xy prime minus y all over y squared. And then here we're going to say we have the root of, now you know that it will be y squared minus x squared divided by y squared, like this part here, right? So that we have xy prime minus y all over y squared. Now we can flip, remember, we can flip them to say you have 1 over the root of y squared. No, sorry. No, wait. Okay. Let's write this as square root of y squared minus x squared divided by the square root of y squared. Yeah. Square root of y squared. Like I'm saying, remember this law we learned in grade 11 that square root of a over b will be that over that. So that's how we wrote it there. And then we still have our xy prime minus y all over y squared. Now we can then say we have the root of y squared is simply y, so we say y all over the root of y squared minus x squared times xy prime minus y all over y squared. Now simplifying that, this will cancel that, so it means we'll be left with xy prime minus y all divided by y multiplied by y squared minus x squared. Is this okay?
Yes.
Because remember here you saw the flipping, right, of 1 divided by a over b. That's how we got this one.
That makes sense.
Ne? Right. Yes, so we flipped it there, and then we had that square root of y squared is y. Okay, so now that we have this, we are not done because we only solved this part. So we are then going to say, okay, it means we have xy prime minus y divided by y into square root of y squared. What? We have what? Y squared minus x squared, I get. Then this one we derive it. I get when we derive that one, remember here we can write it as y squared minus x squared to the power of half. I get.
Yeah.
So we will have half into y squared minus x squared to the power of negative half multiplied by the derivative of what is inside. I get. Which will be 2y. Yes.
Oh no, it's okay.
Okay, 2y times y prime. I get.
Yeah,
Minus 2x. Nice stuff. Very interesting stuff. Algebra is very, very beautiful when you see it like this, because it's always magic that is happening here, right? You have y squared here minus x squared. Now this one here you can actually write it as 1 over 2 the root of y squared minus x squared. And get this part here. Remember, this goes on the bottom to join 2, and get this part goes on the bottom to join 2 because it is a negative exponent, and the half means root. And get perfect. And then here okay, I'm just going to take out a common factor there, 2 as a common factor. We'll be left with y times y prime minus x. And get perfect. Why? Because I see that here there is a potential of something happening. 2 will cancel a 2 there. And get. Then when you multiply both sides, when you multiply by the root of y squared minus x squared, and then you do it the same thing here, you do the same thing to say y squared minus x squared, right? This will cancel that, this will cancel that. And get right. What are we left with now? We're left with xy prime minus y all divided by y is equal to Wow, simply y times y prime minus x. I get.
Yeah.
Now you can multiply, as long as you see a denominator, you can multiply everything by denominator. Multiply by y, and then this you can also multiply by y to have xy prime minus y is equal to y squared times y prime minus xy. Right. Then when you at this part, collect the like terms. Collect those that have prime to say xy prime minus y squared times y prime is equal to negative xy plus y. Take the y prime as a common factor so that you have x minus y squared minus xy plus y. Therefore, your final answer should be y minus xy all divided by x minus y squared. Shoo.
Okay.
I don't know if it's correct. Can you please check for me?
Yeah, basically they just factored out the y, but yeah, it's pretty much the same answer.
Same thing. All right.
Yeah.
Right. So
Okay.
yes.
I'm just trying to see if there's like a different one. Just so like as a last question.
Okay. Alright, so the system is very much the same. The procedure is the same. Make sure that you deal with u, substitute the u, and then deal with the rest. Hold on.
Okay, can we do? I just want to see where I went wrong with 1.12. Still exercise is
1.12.
yeah.
Whew. You know, isn't this? It's like one of the last ones, eh?
No, this exercise goes up until 1.20, and then there's still questions.
Okay. No problem. Cause it looks very interesting.
Yeah, it is interesting.
Right. So here what we have lean, and then we have tan. Right. A lot is going on. However, the basic idea is to say lean we know we can deal with it. The main part is here on tan.
Yeah.
So tan, we have to remember that how do we derive tan? Right, we have to remember that for tan, we said tan inverse, the derivative of tan inverse. We say it is derivative of u all over 1 plus u squared. Angel? Right, this is our u here. So we deal with u first. And we did it before, but then it's fine. U is so we say let our u be y over x. That means the derivative of u would be x squared, and then x times the derivative of y, which is 1 times the derivative of y, minus what? Minus the top part times the derivative of the bottom part. Angel. So you have x times y prime minus y all over x squared as your u. Of which now...
Okay, so this is...
Yes?
Oh, but that was cos. Okay. Okay, wait. Let me try to find something that's not similar to this one.
Okay.
Because as we're doing it, I'm actually seeing that it's very similar to the previous question. Okay. Let me see quickly. It's 10. Okay, you can just continue this one then. I thought most of them looked similar, unless we can do like hyperbolic, just so, because we haven't done a hyperbolic question.
Okay, a hyperbolic question. So what
Yeah,
activity? It's
I
activity
I
what?
have one.
Okay.
We can do activity 9.
Yeah.
We can do like, hmm, let's do 1.14.
1.14. Eh?
Mm-hmm.
All right. All right. Right, let's see that. Copy. Um. Right. Then we can put it. Oh yeah. Still a space. We can put it here. Right. And then maybe let's say behind. Let's put it here. Right. So I'll just put 3 dots to say the same story goes. Then for this
Mm-hmm.
one, it's very nice. We see that we have hyperbolic tan. Now, since we said for for tan inverse, it's root of u 1 minus u squared. For hyperbolic tan, you just change the mood, right? For hyperbolic tan means it will be u prime all over 1 minus u squared, right?
Mm-hmm.
Right. Now that it's like that, we work with that. We simplify hyperbolic tan first, right? To say, okay, our y is there. Now this one is very much nice because our u is just y. So the derivative of u is simply going to be y prime, right? Then from there, we then say for this part, right, we substitute it as 1 over 1 minus u squared, which is y squared, right, multiplied by y prime is equal to, this one we know that it's 1 over y plus 1 times the derivative of what is inside, which is y prime, and then plus 2, right?
Mm-hmm.
Right, so that we say we have y prime all over 1 minus y squared over 1 minus y squared is equal to y prime all over y plus 1, then plus 2. Then from there, we can then say, okay, we need to multiply by this one first. So in multiply by y plus 1, what you will get is that you will get y prime into y plus 1 over 1 minus y squared is equal to y prime plus 2 into y plus 1. So it's just dividing by this denominator. Then we still have a denominator. We do the same thing. We multiply by 1 minus y squared. From metric, when I see a denominator, I multiply throughout. So it means that here we will have this, and then y plus 1, 1 minus y squared is equal to y prime into 1 minus y squared, and then plus 2 into y plus 1, 1 minus y squared.
Wait, why is the one on the left? Why is the 1 minus y squared? Why is it there?
Here, oh, they cancelled each other. Oh, thank you so much. Yeah, they cancelled each other. Okay, so it means when this multiplied that, actually this denominator cancelled there, we're left with y plus 1. Then we collect those with y prime on one side, y plus 1 minus y prime into 1 minus y squared. We leave this one, y plus 1, and then 1 minus y squared. Do not rush to multiply them inside, right? Work with them as they are. To say
Yeah.
y prime into y plus 1, then minus 1 minus y squared. Signs, careful a bit on those signs there before they do something. Then you say y plus 1 minus 1 plus y squared, right? Because negative times 1 is negative 1, negative times that is positive. So now we'll have a y prime into y plus y squared. Right. Then the last thing would then be to say y prime will be 2 into y plus 1, 1 minus y squared divided by y plus y squared. I think there we can simplify further, right? I think maybe we can do something there and say maybe y into 1 plus y, right, as our derivative. Then we then say the derivative will be 2 into 1 minus y squared all over y. That should be the final answer there.
Yeah, it is.
Right. Nice stuff. So even hyperbolic, right, it is still the same procedure that you work with the one inside, you substitute back into the formula, then the rest is history. Right. Okay. I hope that was helpful. And
Yeah, it helped.
no, that's good. No, have yourself a good night. Best of luck on this. Keep working on these things. The time is still there to work on these things.
Yeah.
Right. And I hope also Miss Layla, at least you are following along there, right? I think, great. I know we'll meet each other tomorrow, ma'am. Otherwise, ma'am, thank you and a very good night. Thank you.
Okay.
Yeah, goodbye.
Sharp.